Guys, I'm here now.
It's Yamcha!
That's right. Don't worry, guys. We worked ourselves half to death with our training. So I know that as long as we stick together, we'll take on these Saiyans. And we will win!
Yeah!
So, good day. Ngayon, itutuloy natin yung part 2 ng ating electrochemistry lesson, the redox equation, balancing, solving, everything. So, a redox chemical equations represents the reaction present in an electrochemical cell. So, meron ang tawag doon sa ating mga cells na nagko-contain ng reaction is electrochemical cells, specifically for redox reaction. So, napag-usapan na yun natin last time, di ba? So, like other reactions, it contains a reactant side and a product side. So, the same lang din. Meron tayong reactants and products dito sa ating redox reaction. So, it's like a normal chemical reaction. So, you should take note of that. And however, unlike other reactions, redox reactions concern the transfer of electrons. So, doon sa ating mga balancing chemical reactions, so, napapansin natin, binabalance lang natin yung atom on the both sides. So, in this redox reaction, we balance actually the atom and the electrons from cell to cell. So, and redox chemical equations contains two or more half cells, unlike other chemical reactions. So in a chemical reaction, it may happen on just a single cell or a single place, but in redox chemical equation, there should be more than two or more cells that may be involved. I have read some articles that involve three half cells, pero I am just knowledgeable dahil with two half cells. So this is a cell. So a cell, just like what we talked about last time, so composes of two. So we have here the cell itself, the half cells. This is the half cells, another half cell, and mga half cells natin. So we also had the salt bridge. This is the salt bridge here. And the connecting wire, suppose that we have a wire there. And we also put a voltmeter here. And as we can see, there are two types here of cells. So we have the anode and the cathode. In cathode, it is a type of electrode. So let's consider here the electrode. This is also an electrode, yung anode. In cathode accepts the electrons in a spontaneous redox reaction. So again, for cathode, it accepts electrons. However, for anode, it gives off. So again, for spontaneous processes, so in an anode it is where the electron came from. It gives off electrons, and the cathode accepts the electron. So, ang role ng salt bridge, however, is to maintain the equilibrium of the ions on the both sides. So, we have here, from this, we have here an example. So, ang example natin dito ay copper at zinc. No? We have a copper here on the left side undergoing a redox process, and we also have here the anode. The anode here is the zinc, which gives off the electrons. So annotating this, so we have here two half cells, one half cell which involves zinc transforming into zinc 2 plus. So this one gives off electron according to the figure shown here. So nagbigay siya ng electrons. Yung isa naman tumanggap ng electrons. So as also shown here. Okay. This half cell can also be combined into a one chemical equation called the redox. This is a combined redox chemical equation. So, ang ginawa lang dyan ay pinagsama lang yung mga species na present sa reactants, which is ito rin, at pinagsama lang din yung mga species sa products, at ito naman siya. Kaya nga lang, the equation here is not yet fully balanced. No? So, we also need to consider this type of equations because they are still not balanced. We are only going to the computation first of the cell potentials. And what are these? We will try to explain cell potentials. Now, yan. On the example given earlier, so we have two half cells. So we have anode. The anode is the zinc, which has a potential. So this E is referring to the potential. Oops, wait lang po. This E here refers to the this is a potential. However, this potential refers to the anode. The anode is the zinc. We have 0.76, and a potential for cathode. The cathode here is the copper. So, saan nakukuha yung mga values na yan? So, papakita ko later. Meron tayong tinatawag na SRP o yung standard reduction potential. So, I will give an example of the SRP. At ito, in order to get the E cell is the cell potential. It is the overall potential of the cell, which is the anode plus cathode. So, ang gagawin lang natin, i-compute lang natin siya. Madali lang siya. The E of the cut is 0. The answer here is, let me take my calculator first. The answer is 1.1 volt. 1.1 volt. Let me rewrite. 1.1 volt is the E naught of the cell. However, guys, this is a 1.1 volt. So, paano ba yung ginawa natin? So, meron po kasi tayong assigned values dito. So, ang E-cathode natin is 0.34 at yung sa anode naman natin ay negative 0.76. However, kung titingnan natin yung standard reduction potential, mamaya papakita ko na parang baliktad yung equation na to. Kapag baliktad yung nasa SRP at yun yung nag-appear sa inyong anode, which means kailangan baliktarin nyo rin yung sign. So, you need to multiply it by negative value. Sumobra. Ito lang. Kailangan nyo siyang i-multiply ng negative value. So, kaya yung negative magiging 0.76. You can also use the other one. So, pwede nyo rin gamitin yung formula na E cell. Makikita kung magbabasa kayo. That is E naught of the cathode minus E naught of the anode. Kaya nga lang, if you're using this equation, so yung difference, you don't need to multiply it by negative. So, ilalagay mo lang kung ano yung kanyang assigned value here, and then the formula will do the work. So, para magiging negative 34 siya, tapos minus negative 0.76, and then the answer is also 1.1 volt. Kaya nga lang, I prefer this type of equation kasi dahil dito pa lang pinabaliktad na natin. So, yeah. You will only use this equation if the given state was in standard state. Okay. You can use this equation. If it is on standard state, the nut, the same thing that contains the nut. Here, this is the nut, yung O na to. So, ito yung mga naka-standard state. Kaya nga lang, kung hindi siya naka-standard state, we need to, meaning kapag hindi siya standard state, hindi siya 25 degrees, hindi siya 1 molar concentration, at hindi rin siya naka 1 atm. So, we will use this equation. This is called the Nernst equation, no? We use this if we have given a concentration. So, may concentration yung products and reactants natin, meaning kung may concentration ba yung ating mga cells. Kapag meron kayong given concentration, we will use this formula. So, yung N is just the number of involved electrons. Number of electrons. Mamaya papakita natin kung paano natin nakukuha yun kasi magbabalance tayo. Number of electrons. And then yung Q is, it is a constant by computing the concentration of the products over reactants at a given state which is not on the standard state. Ibig sabihin, kung yung state na binigay sa atin ay hindi 25, hindi 1 molar, lahat, hindi 1 atm, gagamitin natin yung Nernst equation at yung pag-compute nun ng Q ay ito yung formula. Pero kung lahat ay given sa standard state, you don't need to compute for this. You will only need to use this equation here. So, siguro let's try to answer, no? Kung paano natin siya i-compute again. So, let's say given ka ng ganito. So, the formula for this is how can we compute again? Compute na yata natin kanina, no? So, E naught of the cell is equal to E naught of the cathode minus plus E naught of the anode. Okay. So, ang E naught ng cathode natin ay 0.34 voltage plus 0.76 volts. That is 1.1 volts. Yun ang E naught ng cell. Tapos, meron tong ibig sabihin. Mamaya, pag-aaralan natin kung pagka-positive ba ang E-cell, ano siya, kapag negative yung E-cell, ano siya. So, may mga ibig sabihin yung mga values niya. This is E naught of the cell is positive. Spoil ko na kayo. This one is called a spontaneous reaction. And mamaya papaliwanag natin what are spontaneous reactions. Spontaneous reaction or spontaneous redox reactions. So, ito yung mga standard electrode potential. So, this is called standard reduction potential o yung tawag ng iba ay SRP. Mas prefer ko na tinatawag siyang SRP. Kung mapapansin natin, ito yung gagamitin natin para malaman natin yung E naught o yung cell potential ng bawat isa. Pwede nating tingnan is, di ba, given tayo kanina ng zinc 2+, tapos given din tayo ng yung isa ay copper. No? So, ito yung isa. Ito yung first equation, which is the copper. At ito yung kanyang value. Kung makikita nyo, 0.34. Yan, copper 2 plus 2E. Diba? Ito yun. Makikita natin, the value is ito. At hindi natin siya biniliktad because the way we isolate the equation as is siya. And tingnan natin tong isa, yung zinc. Yung zinc ay ito. We have here the zinc on the reactant, zinc 2+. And zinc, oops. Yan. Itong part na to. So, the reaction goes like zinc 2+ tapos naging zinc solid. Kaya nga lang, if we look at the equation, it comes from the zinc solid, then zinc 2+. Kung mapapansin nyo, di ba baliktad? Baliktad siya. So, kapag baliktad, yung nasa reference natin o yung nasa SRP natin, doon sa in-isolate natin na equations, then the sign should be changed. So, we need to multiply the sign by negative. from here, the sign is already negative, negative 0.76. So we need to multiply that by a negative value in order to change the sign by changing to 0.76. Ayan na siya. And then you add. Ganun lang. So, ayun. In order to get the proper sign, kailangan tingnan nyo kung nakaakma ba yung equation natin. So, ito, yung copper. Copper 2, from copper 2 plus naging copper solid. The same lang din naman siya because from here, makikita natin na from copper 2 plus naging copper solid. So, ayun. That's how you get the sign. Okay. In a spontaneous process, this is the redox process though. So in a spontaneous process, or spontaneous redox process, electrons move from the anode to cathode. So this is the anode. So anode, ito, part na to. So mangyayari, mag-undergo siya ng redox here. And then, the electrons will be ejected out from here to here. These electrons, yung electrons na nanggaling sa anode, sasapuhin ngayon ni cathode. So, the cathode gains the electrons. Yan. So, again, the movement is from anode to cathode, in terms of electrons. Okay, this is called a galvanic cell. Yung mga galvanic cell, ang usual na nangyayari sa mga galvanic cell is kapag pinag-connect mo yung dalawang cell, ang tendency is it will gives off electricity. So meron kang makikita na voltage. So usually yung mga voltage na yon ay positive voltages. Positive voltages. Tandaan na yung E naught at also yung E naught ng cell na yon o yung E ng cell is positive. Oops. Positive. Positive dapat yung E naught ng cell nila or the E cell itself. Dapat positive. Take note pagka spontaneous reactions, it normally happens. So normal lang na nangyayari yung reaction. Pagka pinagsama mo sila, pinaghalo mo sila, the reaction will start. However, for non-spontaneous process, yung kabaliktaran, kailangan ng energy muna para mangyari. Okay. Ano ba yung mga reaction na to? In a non-spontaneous reactions, so, non-spontaneous redox process rather, yung electrons baliktad. So it started from the anode. The movement is from anode to cathode. Uy, actually mali yata ito. Sorry. Mali ang arrows. Baliktad siya. Raise ko muna po. The electron here should move from the cathode to the anode. Baliktad. Kapag non-spontaneous reaction, baliktad dapat. So, from cathode to anode. Yung cathode ang magbibigay ng electron. This is a normal, spontaneous. This is a spontaneous, yung nasa figure. Pero kapag naglagay ka ng electricity dyan, let's say dito, inoriente mo siya, maglalagay ka ng energy. Ang tendency is, yung cathode, pag nag-supply ka dyan ng energy or electrical energy, ang tendency is yung electrons ay mag-move from here punta sa kabila. Parang ang ginagawa is, if you supply energy, parang itutulak niya yung electrons pabalik dun sa pinagsimulan niya. That reactions are called non-spontaneous redox process. So, again, yun yung mga non-spontaneous one. Para mag-proceed yung reaction, kailangan kuryentehin mo o painitin mo, magpasok ka ng energy. Ganun. Ang tawag sa mga cells na ganito ay electrolytic cells. Ayan. So, kailangan may input ng energy. Ito kasing nasa figure originally, spontaneous yan. Kasi, nagbibigay siya ng energy pagka pinagsama mo lang siya. Pero, kapag iyaan ay nag-supply ka ng energy sa buong system na yan, ang tendency is yung system naman ay babalik dun sa original state niya o ang mangyayari is the flow of electrons will go backwards. So, the electrons will move from the cathode to anode. Tandaan, pag electrolytic cell, cathode to anode ang move. Unlike naman dun sa isa, kapag spontaneous redox o dun sa mga galvanic o voltaic cells, usually, ang galawan is from anode to cathode. Okay. Ito yung isa kanina, binalikan natin. However, this type of equation is actually unbalanced. So, we need to balance it muna. So, key in balance, how do we balance a redox chemical equation? So, makikita natin sobrang tedious niya, ang haba-haba. At, nag-i-involve siya ng charge. So, ito yung nagpapahirap sa kanya. Unlike dun sa balancing, at titingnan mo yung atoms, ito pati yung charge. Excuse me. So, yun. How can we balance the redox equations? So, first, you need to identify the half cells. So, kapag kunyari, given kayo ng ganito, ganitong type of equation, hindi siya balanced na mahaba, kailangan hahatiin mo siya into two parts. At paano natin siya hahatiin? You look at the key atoms. Yung mga key atoms natin is yung the same atom doon sa both sides. For example, we have zinc. We have zinc on the left and we have zinc on the right. That's one half cell. Ito. So, ihiwalay natin siya. Another one, we have copper. Yung copper dito at saka yung copper dito. So, yung copper sa left, yung copper sa right. Yung copper sa left ay copper 2+. And yung copper sa right naman ay copper solid. So, ayun. Pinaghiwalay lang natin siya. Okay. So, I need to erase muna yung mga annotations. Next is, after identifying the half cells and separate them, after we separated them, we need to balance the atoms naman. Balance the atom in each half cell. Okay? And so this is where we apply our balancing skills. So, we need to apply. So, hindi tayo magfo-focus muna dito sa mga charges. So, huwag muna natin focusin yan. Focusin muna natin yung atoms. So, makikita natin, we have here one zinc and one zinc sa left, one zinc sa right. So, this one is already balanced. Wala na kayo ilalagay. The same with copper. The copper already was balanced na rin. Wala na kayong ilalagay pa. Just stick. Alam? Okay. So, may inayos na ako. So, this one is already balanced. Ayan. So, since na-balance na natin yung atoms, next is kung may mga oxygen, we need to add H2O doon to balance the oxygen. Okay? Meron ba tayong oxygen na mga present? Wala tayong oxygen. Wala. Wala tayong oxygen sa left and right ng mga half cells. Wala. Next is, we balance the hydrogen by adding either H, kung acidic, tandaan, naka-indicate ito. Kung acidic, you need to add H. Kung acidic conditions. At kung basic naman, we need to add OH. Pero medyo mahirap yung 3 base. Okay. So, since wala naman tayong H dito sa equation, so we can disregard it muna. So, since wala tayong babalance na H, you don't need to balance the H. And we will proceed to the next step. Balance the charge. Okay. So, ito naman, yung sa first part ng electrochem. So, kung naalala nyo yung balancing, assigning oxidation number. So, ito yung mai-apply natin. Dito natin mai-apply yun. So, the charge here is actually +2 on the right. And this one, ang charge naman dito ay 0. Dito ay +2. So, hindi balance yung charge. Paano natin i-balance yung charge? We need to add electrons. Yung electrons, ang charge niya ay -1. So, ilang -1 to balance out the +2? So, we need to add 2 electrons. We need to add, again, this is +2. And this is 0. Add tayo ng electrons, dalawa, para siya ay 2 times -1. So, ang total charge natin ay -2. So, +2, ito, -2. equal to 0. So, the total charge here is balanced doon sa kaliwa. So, ayan yung ating final half cell. The next one is we need to also take note of this. So, this is plus 2 and this is 0. So, we only need to add electrons which is negative 1. So, how many electrons yung kailangan nating idagdag para ma-balance out yung plus 2? So, ang kailangan natin ay actually dalawa din. Kasi, plus 2, tapos ito magiging minus 2. Pag pinag-add natin yung dalawa, ang total ay 0. So, dapat kasi nakabalance din yung nasa left dun sa right in terms of charge. So, the final equation here is, siguro, punta muna ako ng notepad. Wait lang guys. I will open a notepad here. Ang gagawin natin actually is i-rewrite natin yung equation with balanced charges. So, again, gamit ko lang yung brush. So, you have zinc solid plus is to zinc 2 plus 2 electrons. Tapos, we also need copper 2 plus 2 electrons yielding copper solid. So, ito yung balance redox equation. So, ang gagawin na lang natin is pag-a-addin natin sila. Napakadali na lang. Ito na yung last part, add and combine. So, kung mapapansin natin, may dalawang electrons dito sa left at may dalawang electrons sa right. Kailangan mabalance out natin yung electrons na yon in order for us to kailangan ma-cancel out natin yung electrons from both sides. So, yun ang pinaka-kailangan nating rule in adding. So, i-rewrite na lang natin yung mga ano. So, this one is zinc solid. This is copper 2 plus zinc 2 plus this copper solid. So, ito yung final balance chemical equation. So, balance. Going back. So, yun din pala yung balance. No? So, just to give you more, ito yung galing sa book kung paano mag-balance ang chemical equation. So, you can actually pause the video and take a screenshot and you can read this. Pero, I suggest na ganito yung gawin nyo since this is a lot simpler. We will also try to solve balancing chemical here, these examples. So, I think I will dedicate a separate video for this in order to balance this 3 examples. So, ganito na lang yung ating lesson and then I hope medyo marami kayo nalaman. And also, may exercise dito, sagutan nyo to. Ipapas din to doon sa final deadline natin hanggang end of September. No? So, the same lang din, gagawin nyo siya sa paper, tapos iaano nyo siya. I-picturean and then isa-send sa Google Classroom. So, yun lang and thank you for listening and watching. Ayan. So, stay safe and aral mabuti.